morning students, welcome back to your physics online class. Students, in the last tutorial we have discussed the dimension. Last topic was dimension of the physical quantity. We have defined the dimensions of the physical quantity, and also we have seen how to find the dimension formula of a quantity. In the last tutorial it was speed or velocity, I think, for which we have calculated its dimension formula. Now let's see some more physical quantities for getting its dimension. Let's practice some more. Let's see, the second physical quantity here is acceleration. For which we are going to find its dimension. Symbol A, you know that symbol is A, we are using for acceleration, and you know that acceleration means rate of change of velocity. जैसा कि मैंने लास्ट लेक्चर में बताया था कि for getting the dimension of the physical quantity we need its first formula, है ना. First of all we should know its formula. So you know that acceleration formula is change in velocity upon time interval. This is the formula, basic formula for acceleration. A equals to delta V by delta t, means change in velocity upon time interval. So check here, dimension of A. Dimension of A means dimension of this ratio. Dimension of A means dimension of this ratio, and dimension of this ratio means dimension of change in velocity upon dimension of time interval. And note down the change in velocity, important line you should note down. The dimension of change in velocity is equal to the dimension of the velocity. Repeating, the dimension of change in velocity is equal to the dimension of velocity, because basically change in velocity is what? It is, quantity is velocity. So dimension of change in velocity means dimension of velocity, and we have calculated it. This is LT minus 1. This is LT minus 1 in square bracket is the dimension of delta V. And now dimension of delta T. What is T? T means time. So time interval dimension means dimension of time. So this is T. In square bracket we are using. So exponent law you can use, like x upon y equals to x y to power minus 1, है ना. This is one of the exponent law we have studied in class 10th. So similarly, when t goes in numerator with exponent opposite sign, so finally we have L t minus 1 and t minus 1, and again t minus 1 means t to the power minus 2. So finally we have dimension of acceleration is in square bracket LT minus 2. So this is the dimension of acceleration. और यहीं कोई पूछ दिया कि what are the dimensions of acceleration? Repeating, what are the dimension of acceleration? So we have to write 1 in length, जैसे कि लास्ट लेक्चर में समझाया मैंने, 1 in length and minus 2 in time. So this is the way by you can express the dimensions of a physical quantity. और ये क्या होगा? This is the dimensional equation. ये पूरी जो स्टेटमेंट दिख रहा है, बॉक्स कर दिया मैंने जिसे, this is the dimensional equation. और तुमसे कोई पूछ दिया what is the dimension of A, so just write LT minus 2. It is LT minus 2. And don't miss to use the square bracket. Square bracket में ही express करते हैं dimension of a physical quantity. Similarly, you can practice for some more physical quantities to get its dimension, है ना. So this is the way how to find we can find the dimension of the physical quantity. Now let's say it's a very important part, applications of dimension. Applications of dimension. Note down your heading. Applications of dimension, या ये लिख सकते हो डायमेंशनल एनालिसिस. हेडिंग हो गई applications of dimensional analysis. In this part we have 3 applications, in which first is to convert a physical quantity from one system of unit into another. So this is first application of dimensional analysis method. See what is the application? To convert a physical quantity from one system of unit into another. It means we can convert a physical quantity from one system of unit into another with the help of dimensional analysis method. It means this application is based on the fact, listen again, this application is based on the fact that the quantity of a physical quantity, the quantity of the given physical quantity remain conserved, remain constant, whatever be its unit. For example, you have a substance, means suppose you have a vegetable, है ना, 1 kilogram potato suppose you have, then this is the quantity of the substance in SI system, yeah, MKS system you can say. This is in MKS or SI system. And when you convert this quantity into another unit, like another system of unit like CGS, so you have to write here 1000 gram. Is it true? Is it correct now? The amount of substance is 1 kilogram in MKS system, means in one system. And in another system, the quantity is 1000 now, written is 1000 but in gram. So fact is that both are same in quantity. 1 kilogram likho या 1000 gram likho in different units, but the quantity remains same. This is the basis on which we use this application. Let's see. So क्या है? Conversion of the physical quantity from one system unit to another system of unit. Right here, one example here. Suppose question is there, the given force is suppose of 5 joule. Sorry, work you can write here. The given work is 5 joule. Find the equivalent work in CGS system. This is the question. The given work is 5 joule and you have to convert this work into CGS system. बोला है find the equivalent work in CGS system now. So this is the question based on this application. Let's see. So for the solution of this type of question, remember one formula which we have discussed in earlier lectures. N1 U1 equals to N2 U2. I think this was the topic, this was the formula we have discussed in first lecture of the second chapter. ठीक है ना, of this chapter. In first lecture we have used this formula, we have defined, means we have described this formula, n1 u1 equals to n2 u2. फैक्ट वही है, वॉट एवर बी द सिस्टम ऑफ यूनिट, मीन्स u1 यूनिट हो या u2 यूनिट हो, बोथ आर सेम, ठीक है, द क्वांटिटी रिमेन्स सेम. सी है व्हाट इज n1, तो लिखोगे n1 इज द न्यूमेरिकल वैल्यू ऑफ द गिवन क्वांटिटी इन फर्स्ट सिस्टम, n2 इज द न्यूमेरिकल वैल्यू ऑफ the given quantity in another system, you mean second system, and u1 u2 are the units of the given quantity in two system of units. So using this formula we can write it as, suppose you know the n1 means first system में numerical value दी है, like here suppose our first system is mks or you can say SI system, and second system here is CGS. So first is MKS, second is CGS, and you know that the numerical value of the given quantity, कौन सी quantity है, work. The given quantity is work, and of this quantity the amount numerical value of this quantity in first system is 5. So 5 is given, suppose 5 is given, this is n1. n1 means numerical value of the given quantity in first system, और first system में इसकी value दे रखी हुई है 5. We have to find it here n2. n2 निकालना है आपको. We have to find here the n2. So using this formula, what is n2? n2 equals to n1 and u2 by u1 by u2. u1 by u2, and using the dimensional method, analysis method, you can write this relation as n2 equals to n1 m1 by m2 to the power a l. You can start from l1 l2 to the power a, m1 by m2 to the power b, and t1 t2 to the power c. ठीक है, या m से स्टार्ट कर सकते हो. बाय डिफॉल्ट जनरली वी यूज mlt ऐसे, तो करेक्ट दिस अगेन, बोथ आर सेम, बोथ आर करेक्ट, बस this is the sequence or order in which we use the dimension of the physical quantity, MLT, sequence ऐसे रखते हैं MLT. So now this is our formula, इस फॉर्मूले का यूज करके अब इस क्वेश्चन को हम सॉल्व करेंगे. फॉर्मूला नोट करें, n2 equals to n1 m1 by m2 to the power a, l1 by l2 to the power b, and t1 by t2 to the power c. where n2 बता दिया, we have to find the numerical value of the given quantity in second system. n1 is given here, that is 5, या कह दो numerical value of the given quantity in first system. abc, now write down abc. क्या है abc, देखो abc are the exponents, या power you can say, are the exponents of किनके, MLT, mass, length and time in the given quantity. What is the given quantity in the question? Work. तो वर्क के डायमेंशन में ए बी सी क्या होंगे? द एक्सपोनेंट्स ऑफ मास, लेंथ एंड टाइम करस्पॉन्डिंगली, रिस्पेक्टिवली. ठीक है. सो एंड व्हाट आर m1 m2? तो कहेंगे m1 is the unit of mass in first system, m2 is the unit of mass in second system. L1 is the unit of length in first system, L2 is the unit of length in second system. Similarly, T1 and T2 are the time units in first system and second system. So first of all we need this ABC. ABC क्या है बता दिया, exponents of mass, length and time in work dimension. So let's find here the work dimension first. Separately you can find work. What is work? Work formula equals to force into displacement. Force into displacement. So dimension of work equals to dimension of force multiplied by dimension of displacement. Dimension of force, you know that mlt minus 2, this is dimension of force, and displacement means basically length, this is L, combining ml2t minus 2. See, this is the dimension of work, ml2t minus 2. So you can find here ABC. A क्या बताया मैंने, A is the exponent of mass, B is the exponent of length, and C is the exponent of time. So from this relation, A equals to 1, B equals to 2, and C equals to minus 2. Now we have ABC. अब ABC पता चल गया क्या है. जब ABC है, now put the values in the given relation, given formula. ठीक है ना? फॉर्मूला है आपका. सो नाउ n2 निकालने चल रहे हैं. व्हाट इज n1 इज गिवन 5 एंड m1 बाई m1 मीन्स मास की यूनिट फर्स्ट सिस्टम में इट इज kg एंड मास की यूनिट इन अनदर इट इज ग्राम. यू कैन राइट हियर 1 kg 1 ग्राम टू द पावर 1 ना, बिकॉज a is 1 and L1 by L2. L1 means length unit in first system, it is meter, and in series system it is centimeter, to the power b का मतलब हुआ 2. And for time, you know that in MK system or in series system both are second, so this is 1 second, and to the power c means minus 2. ठीक है. Finally n2 equals to, अब now you know that this is kg, this is gram, and finally you have to convert the value in cgs. so kg को भी cgs में convert करो, मीटर को भी cgs में convert करो, और ये तो पता ही है सेकेंड, ऑलरेडी सेकेंड ही है, चाहे किसी भी सिस्टम में चेक करो. Finally तो then 5 and this is 1000 upon 1000 gram, and this is 1 gram and 1, and this is 100 centimeter upon 1 centimeter to the power 2, and this is, you know that 1 by 1 1, and 1 to the power minus 2, it is 1, just 1, so this is 1 second. Now let's simplify this relation, this equation. 5, see this 1000, this is 1000 means 10 power 3, 10 to the power 3, 100 to the power 2, see this 100 to the power 2 means 10 to the power 4 into 10 power 4. यूनिट तो है ग्राम, ये है, ये सेंटीमीटर स्क्वायर है, एंड दिस इज सेकेंड. अब यूनिट ने इसकी वैल्यू लिखी जा रही है. सो दिस इज 1000 मीन्स 10 पावर 3, 100 अपॉन 1 मीन्स 100, 10 पावर 2 हुआ, 10 पावर 2 पे 2, 10 पावर 4, एंड दिस इज 1. एंड यूनिट, व्हाट इज यूनिट नाउ? ग्राम सेंटीमीटर स्क्वायर सेकेंड, ग्राम सेंटीमीटर स्क्वायर सेकेंड. So now n2 equals to 5 into 10 to the power 4 plus 3 7, and gram centimeter square second, gram centimeter, and this is minus 2, it was there. So gram centimeter square second, it is now dyne. Okay, this is the answer, this is the answer. Or directly you can write here, don't write gram centimeter because this is in in proper order, just write dyne directly, because in CJ system unit of work is dyne, 500/7. This is the conversion. Now let's see the second application here. Second application of dimension. Write down, to check the correctness, of a physical relation dimensionally. This is the second application of dimensional analysis method, to check the correctness of a physical relation dimensionally. So before starting this application, first note down one important, very important application, means principle is there. ठीक है ना? Note down the heading, principle of homogeneity. Principle of homogeneity. Very important. It will use this formula, this principle will be used in second application as well as in third also. So very important principle is there, principle of homogeneity. Write down it, what is the principle? This principle says that if a physical relation means physical formula, means a formula used in science, means in physics, usually in physics only, है ना? The equation, or in chemistry also you can use. So the physical relation or formula is dimensionally correct only if the terms on both sides of the relation will have same dimension. See here, for example, x equals to y plus z. Suppose this is the relation, example is there, just x equals to y plus z. Suppose this is the physical relation, एक formula है, and this formula will be dimensionally correct if dimension of x equals to dimension of y equals to dimension of z. बात समझो, बताया रिलेशन के दोनों साइड में, ऑन बोथ साइड ऑफ द रिलेशन, मीन्स इक्वल के लेफ्ट, इक्वल के राइट, द इंडिविजुअल टर्म्स विल हैव सेम डायमेंशन. तो यू कैन काउंट हियर, in left side it is just one term x, and in right hand side there are two terms y and z, because terms are separated by plus or minus only. अगर यहाँ पे लिखा होता y into z तो it is just one term, but अगर ऐसे लिख दिया है x plus minus y, sorry, लिख दिया y plus minus x, so this is, sorry, x नहीं z कर दो. अगर क्या दिया कि y into z होता तो y into z में क्या कहते हैं, it is just one term, but here y plus minus z होगा तो it will be two terms. So कह रहा है कि लेफ्ट साइड में जितने भी टर्म्स हैं एंड राइट साइड में whatever be the number of terms, all will have same dimension. So dimension of x equals to dimension of y equals to dimension of z. और यही अगर रिलेशन ऐसा होता है x equals to y z, तो कहते हैं डायमेंशन ऑफ x equals to डायमेंशन ऑफ y z. क्या कहते हैं? डायमेंशन ऑफ x equals to डायमेंशन ऑफ y z. या अगर लिखा होता कि x equals to y by z, सो कहते हैं डायमेंशन ऑफ x equals to डायमेंशन ऑफ y by z. किस कंडीशन में? व्हेन दिस रिलेशन इज डायमेंशनली करेक्ट. जब कोई रिलेशन डायमेंशनली करेक्ट होगी, सो उसके दोनों साइड में the number of terms means whatever the number of terms, all will have same dimension. This is the principle of homogeneity. So we will use this principle in this second application. आपने लिख लिया होगा second application. What is the second application here? So to check the correctness of a physical relation dimensionally, is it correct or not? So you can use here one example to explain this method. We have one example. Write down the question. Check the correctness. To check the correctness of third equation of motion. We have to check the correctness of third equation of motion. You know that equation of motion, third equation is v square equals to u square plus 2as. This is the third equation of motion. Now we have to check is it dimensionally correct or not. How? So we have two sides again, left side, right side. So here in left hand side, how many terms are there in left hand side? It is just one, v square. So dimension of v square. V means velocity, final velocity, and its dimension is lt minus 1. We have calculated earlier. And square का मतलब हो गया 2 exponent लग गई. Finally L2t minus 2. L2t minus 2. This is the dimension of v square. या क्या तो dimension of left hand side. ठीक है? Left hand side term. Not left hand side. This is the dimension of left hand side term. This is just one term. And in right hand side, how many terms are there? Now see two terms. One is u square, another is 2as. So we have to check both separately. So dimension of u square, you know that u and v both are same physical quantity, velocity. This is final, this is initial. So basically velocity. So this will have the same dimension as of the v square. So कह सकते हैं this will be also L2t minus 2. चेक कर सकते हो. u को फिर से लिखोगे lt minus 1 and square लगाओगे तो you will get L2t minus 2. Now check the third dimension of 2as. अब देखो dimension of 2as में we don't means we have to find the dimension of a into s only, not for 2, because you know that 2 is the constant. 2 का कोई डायमेंशन नहीं होगा, ठीक है ना. 2 का कोई डायमेंशन नहीं बनता है. सो वी हैव टू चेक हियर द डायमेंशन ऑफ a into s. a into s, where a is the acceleration and s is the distance or displacement. सो एक्सेलरेशन के लिए जानते हैं L2 minus 2 आज ही कैलकुलेट किया हुआ है, and s this is basically length. So finally combining L2t minus 2, equation number 3. So check here. Left hand side v square dimension L2t minus 2. Right hand side both the terms having the same dimension L2t minus 2, L2t minus 2. So this relation is dimensionally correct. ठीक है? This relation is dimensionally correct. So this is the way by which we can find the by which we can check the correctness of a physical relation. Write down some homework, some question for the practice. Question लिखो. Write down the question now. The displacement of a progressive wave. The displacement of a progressive wave is y equals to a sin omega t minus kx। ये फॉर्मूला आप जो है इस 11th के सिलेबस में सबसे लास्ट में देखेंगे फिजिक्स में, इन चैप्टर नंबर 15, ठीक है ना। बट वी कैन यूज हियर दिस रिलेशन एज द एप्लीकेशन ऑफ दिस डायमेंशनल मेथड। The displacement, this is called the displacement relation in the progressive wave, where write down where x is distance, and you know that y is also given here, displacement. Y is the displacement, x is the distance, and t is the time. क्वेश्चन है write the dimensions of या डायमेंशनल फॉर्मूला कह दो, डायमेंशनल फॉर्मूला ऑफ फर्स्ट इज ओमेगा। This is called omega, not W. This is not W, this is omega. You know that omega is the angular frequency. Omega, and second one is K. Small k. This is another constant. So we have to find the dimensional formula of omega and K. ठीक है, हिंट भी मैं आपको कर दे रहा हूँ यहाँ पे। एंगल डायमेंशन इज नथिंग, या कह दो एंगल डायमेंशन, या कह दो देयर इज नो डायमेंशन ऑफ एंगल, देयर इज नो डायमेंशन ऑफ एंगल। एंगल का कोई डायमेंशन नहीं होता, एंड व्हेन वी रिक्वायर टू शो द डायमेंशन ऑफ एंगल वी जस्ट यूज 1। जब कुछ नहीं निकलेगा तो क्या कह देंगे, वहाँ पे 1 लिख देंगे। सो यूजिंग दिस हिंट यू हैव टू फाइंड द डायमेंशनल फॉर्मूला ऑफ ओमेगा एंड के। सो दिस इज योर होमवर्क। So for watching this video, thank you very much and God bless you.